got this. Okay. All right, all right.
Okay.
This, I think it's at below here. Okay, so I'm gonna keep using this perf account example.
Of
Uh,
course.
so I want to talk about how to test with mutation. So it's going to
Mm,
be a bit interesting. So let's go to line 257. I'm going to write some tests. So again, I'm gonna do this for you just to show you how things are done. Um, so testing is a bit different with mutation. So usually, right, when we test with non-mutation, we can like call function, right? And then we pass it one,
right.
two, is three. We can do this, right?
Okay.
So some of the consequences of mutation is that firstly, remember it can quote unquote return multiple values, like multiple things can change.
Yeah.
So because of that, so I'm gonna write this because multiple things can change, one is 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 insufficient. Okay?
Okay.
Um yeah.
Do we need like ends or something?
So yeah, I'll show you in a moment. So let's start small. I'm going to move this account example. No. Actually, no, I'm not going to move the account example yet. So ACTT1, 9254, I'm going to leave it outside. So let's keep it simple. Oh, I already have 9264. I'm just going to move it in here. So let's say we call perform transaction. Notice how
Mm,
that doesn't even produce anything. I can't even use is. Like, I can't do this. I can't, right?
yeah. Yeah.
Like,
Right.
if I did this and I run it right now, it's going to say it doesn't, yeah, the test will fail. And it will fail because the left's, huh? Oh, I think I might have trolled.
Oh, it does
I
return something, right?
it does return something. Oh, is that how they do it? I think whenever you do a side effect, it gives you back the same thing. Sorry. Backtrack. It
Okay.
produces the account. Okay, yeah, it
Okay.
produces the account. Sorry, my bad. Okay. Um, what if I do this? Okay, when we go to C++, then what I say will make sense. Okay, account one
Okay.
gives us that, right? Now, but what
Yeah.
happens if I do this? Expected account one equals account 8404. You see what I'm doing?
Yeah. You mistyped like six.
Oh, oops. Thanks. Now, if I run this,
Right.
okay, you see what happened here?
Oh, the the like test one failed is so hard to understand the like details because the left side and the right side the both sides are the same, right?
Yeah,
So if we don't look at the code,
but
it's
how could they
impossible
possibly
to
fail?
understand.
How could they fail? They're the same thing, right? I mean, you and I were looking at it,
Mm,
right? They're both 8404 and 10500.
right,
So why is it failing?
because it has the same ID and the same uh, like balance, but it's not like the same pointer, right, on a stack or something.
Okay, yeah, okay. Since you did C++, you know some ideas about this. Um, okay, I'll talk about it. I'll talk about it. So I was planning to save this with mutation. Notion, there is an additional notion of equality. Last time,
Okay,
we we two things are the same when they are made of the same things, right?
mm,
For example, let's say we
right,
have let's say we have two identical twins. Are they the same human being? Last time we say yes because their DNA is the same.
Okay.
But now, let's say one twin gets injured. Will the other one get injured?
Uh, no, it won't, right?
Yeah, I mean, yeah. Unless they're psychic. If one twin gets injured,
Yeah,
only that twin gets injured, right?
yeah,
So we can say, oh, they're different people, right?
right.
Now, two things can be made of the same thing, but they are still different because they are different objects.
Right.
I want to hold on this thought for now. I think you understand this because you have some experience with C++, but I do want to explain this further later. Okay. So what this also means is that when I want to compare it, if I do this, does this test, like line 261, does this tell us anything? Whether or not our function is working? Sorry, our
Mm,
procedure is working.
yeah, it does because it means that we are changing like the exact same account, right?
Okay. But how about the balance? What happens if like I want to add 10,000, but actually it's removing 10,000 from my account?
What? What?
So for example, let's say I change the
Right.
delta to minus. So line 256, I change the plus to a
Mm,
minus. I'm going to
right.
click run. The test will still pass, but I just lost a shit ton of money, right?
Right.
So is this procedure working as intended?
Like I can say why not? Like I think it is.
But let's say the definition of a transaction is that if the delta is positive, you should be getting more money into your account.
Oh, okay, okay.
Yeah,
Okay.
based on the definition, which you say the
Mm,
procedure is working as intended.
okay, it isn't.
Okay,
So we need some other kind of comparison other than is, right?
okay. So here are some other techniques. Okay, this one you don't really need to know it for competitive programming, but I think it's good to know. So I'm just going to show you. There are some ways to get around this. For example, what we can do is we can say, okay, ACCT1, what is your balance right now? Oh wait, sorry, I have to do this. What is your balance right now? And is it 10,500? Right?
Okay.
Okay, now the test fails. Now if I change the minus back to a plus and run it, now it passes.
Okay. Okay.
So testing techniques, I misspelled it. This my C is a bit broken on my keyboard. Okay. Uh, First is ask for a specific field. No, check a specific. Sorry, I should say check a specific field of thanks of the mutable thing. Okay. You sometimes you can do this, sometimes you can't do this. For our purposes, let's just say you can do this.
Okay.
In fact, because anything about the object can say, change, right? So we should really also check about the ID. We should also verify that the ID
Yeah,
doesn't
right.
change.
Right. So we should
Okay.
check like all the individual fields, right?
Yes. Sometimes you might ask, oh, let's say we have like 50 fields. Isn't that kind of annoying? I'm not going
Yeah.
to show you how to do it, but there is a way to define a custom equality. So like, I'm going to write observation number two. You can write a custom equality function that does, I'm going to call it structural equality.
Okay.
Structural equality is when you compare the two structures. Like, they mean the same thing. Actually, this dichotomy is actually extensional versus intentional equality. Extensional means structural equality, essentially. Are they made of the same things? Intentional means are they like the same object?
Right, right.
So this is a bit of vocabulary, which I don't think you will hear about any time in your life again.
Yeah.
Okay. Okay, yeah, back to our testing on line 263. So yeah, we can actually define a custom equality comparison, and then we can actually ask is, I forgot the syntax, but it's like something like this. No, it's not that. I think it's percent.
Okay.
Like it's something like this. I think my syntax is a bit wrong, but like we can tell is I want you to use my custom equality comparison. Um,
Okay.
so this is a bit of shorthand. Again, different programming languages will have different facilities. For now, let's just keep it simple. Let's just do it a long way. Okay.
Okay.
Uh, yeah. So that's testing this. When testing with mutation, there are actually multiple steps. Last time we can just do is like just one line, but now there are four steps first. Okay, there's a step that I haven't talked about yet. The second step is to make the change. So in this case, line 264 is making the change. Step 3, observe that the changes are correct and there are no unintended changes. There is a step 4 that I'll talk about in a moment. Okay, so now talking about step 1. Let me give the situation. Uh, let's say, just humor me for a second. Let's say I have a new situation here. I want to perform transaction on ACCT1 and I'm going to remove all the money. Okay.
Okay.
And now I want to verify that the balance of ACCT1 is 0. Will this test
Hmm.
pass?
It won't, right? Because
Why not?
we changed it earlier in where.
Okay, very good. Very, very
Yeah.
good. So this, so one of the, if you scroll down to line 290, one of the observation we made is that time is a factor.
Time is, yeah, right.
The
Yeah.
value of something will be different depending on when you look at it. So ACCT1, we looked at it past line 266. Now, what happens
Yeah.
if I move line 271 to 274 to shit, I can't even do that. Okay, sorry. Let me swap the two. Let me swap the
Mm.
two tests, and now I run it. Now the different tests fail, right?
Right.
Now it
Yeah.
is the adding 10,000 that's failing. Okay?
Yeah. Yeah.
But here's the thing, the code is the same. The only difference is where we place the code. The only difference is when they're run.
Yeah.
Now
Okay.
the order of things can make our tests fail differently.
Mm. Right.
So, okay, for competitive programming, you don't need to know this. But for software engineering, this is very important.
Yeah.
Sometimes you can run tests and you get different results. Why do you get different results? Mutation. If you don't handle mutation properly, you will get different results every time.
Okay. Okay.
Sometimes this is intended. For example, if you play video games like Minecraft, if you play Minecraft, you load up a world, you get a different world every time, right?
Right.
There's some mutation happening underground. I'm happy to talk about that next time, but that's intended because you don't want people to keep playing the same world. But imagine if like things keep changing unexpectedly, you can't test the game properly. You can't properly play the game, and that's why bugs happen, right? Bugs happen because you do something and something different happens, and you don't like that.
Yeah.
So mutation is incredibly dangerous. It's the worst kind of bugs. It's the kind of bugs that's hard to track down. Sometimes it appears, sometimes it doesn't appear, and it changes form. That's the worst kind of bugs. What causes
Mm.
that kind of bugs? Mutation. Okay. Again, for competitive programming, you don't really need to know this, but for software engineering, very fundamental, very important.
Okay.
Okay.
Like probably like competitive programming won't like get me that far, so I will like end up in software engineering.
If you really love programming, then yeah, that's what's gonna happen to you.
Yeah.
Yeah. Okay, so I want to talk about back to line 262, the question mark here. We call this the setup. If we want to have distinct tests that doesn't depend on how the other tests are run, we need to move ACCT1 inside of our tests. And I'm going to do that for each. If I run now, I believe this will fail because we've reused the name ACCT1. So I'm going to delete line 251. I'm just going to
Okay.
comment it out. I'll leave a note.
Okay.
Note commented out because we move it to each of the test setup.
Mm.
Okay.
Okay.
But now you might say, wait, isn't it a bit annoying? Line 267 and line 275 are repeating code now.
Right.
So I'm not going to cover this now, but what we can also do is we can do like get setup. Like on line 267, I can change it to get setup, which is a function that returns all my accounts. And here, instead of ACCT ones, I can say accounts. And then ACCT1 will be the first account. Okay, I don't think
Okay.
I showed you this syntax yet, but to get the first account, I'll do ACCT0. Okay?
Okay.
Sorry, I should say this accounts. You see that line 267, 268?
Right. Yeah.
Um, I I'll leave this up to you whether or not you want to do this. This is like for software engineers.
Yeah.
I'll leave this up to you. If you feel like it will help you do this, I'll let you do it. If you feel like it's easier to just do the like what we did just now, which is we define a local variable here. If you believe this is easier, you can do this also. I won't impose any
Uh,
restrictions.
like both works great. Yeah.
Yeah. Yeah, the benefit of this way is it's faster, but more code. The benefit of the other way is it's shorter, less code, but you have to do the infrastructure. You have to write code for the infrastructure, which will pay off in the long
Yes.
run. Okay, so the first step is setup. You set up all your things, so you start from a clean slate so that the effects of the other tests doesn't affect your current test.
Mm. Yeah.
The final step, you don't always do this, is tear down. We're not going to cover it here, but sometimes, I'll give you an example. Let's say you're running some service, you're testing service. You start the server, you do the test on the server, and then you have to close the server.
Okay.
For example, okay, yeah, this is quite advanced. So I'm going to say you don't need to know this. For our purposes, you really don't need to know this.
Okay.
Okay, so I've just talked about testing. Okay, so I want to summarize. Testing with mutation is different because values can now change. Multiple things can change. One is no longer sufficient. We can't do one line tests. Our tests are now multiple lines. We have to do setup. We have to make the change, and we have to observe the changes.
Yeah.
There are multiple steps to our testing now. The second thing is that equality is also different. There is extensional and intentional equality. Extensional equality is what we have done in the past, where we compare the structure of things. Intentional equality is we're asking, are they actually the same thing? Okay.
Okay.
Uh, I want to talk about another idea now. I'm gonna go down to uh where should I do this? Okay, I'm gonna go to line 279 now. I'm gonna do this.
Okay.
Let's not do that. What should be the balance of account two?
Mm. Like 10,000, right?
Okay. Why do you say 10,000?
Because first we like declared that the account two is the same as account one, right?
Okay, let's run it. Yeah, you
Okay, checks
clever
out.
guy. Okay, okay. This is a common misconception. Some people might say it's zero
Oh, really? Why?
because okay. Have you in C++, have you heard of the copy constructor?
Uh,
Have you heard of that copy?
yeah, yeah, like
Oh, like
maybe
yeah.
not in C++, but definitely in Python, right?
Okay. Okay, so I think I have to talk about this in C++. When we move to C++, I'll talk about this, but there's a difference between copy and aliasing. Some people believe that when we do ACC2 equals ACT1, we get a copy of the account. This is not
Yeah.
the case in this
Okay.
language. What you described is correct just now. ACC2 will refer to the same account as
So
ACCT1.
it's like the same address, right?
Yes. When we talk about address, we're talking about like computer internals. That's
Yeah.
why I want to avoid that word. I prefer to say object. They're the same object.
Okay. Okay.
Yeah.
Right.
So I want to leave a note. This is not copy. This is alias. Very important difference. Okay. What is
Okay.
alias? When two names refer to the same object,
Right.
the we say they are aliased. You know, like in real life, when we say like alias, it's like an alternative name, right?
Yeah.
Like for example, when you sign up for these sessions, I ask people like you're allowed to use an alias. This is what I mean. You're allowed to use a
Mm,
different name. Even though you have multiple names, the names are referring to the same person, right?
right.
So here, account two and account one, they are alias for the same account.
Yeah.
A lot of software bugs are because people do not understand this properly.
Mm,
They
right.
are they are referring to an object which they think is referring yeah, okay, I'm not going to get into it right now. I might get into it in the future, but this is a
Okay.
source of a lot of pain in people's lives.
Mm,
Okay. Um, okay, so there's another concept I want to talk about, aliasing. I want to now talk about I'm going to share my screen for a whiteboard now. I'm going to do some ugly drawings, and I'm going to talk about how to conceptualize all this. Uh, schedule. Okay, let me know once you see my whiteboard.
I can see it.
Okay, great.
Right.
So I was doing this with another student.
Mm,
Okay, so I'm going to introduce what's called the box and arrow diagrams.
a box. A box.
Yes, it's to
Oh,
give you a
nice
mental
font.
model. Oh, thank you. Yes, Excalibur is a good website. It's to give you a mental model of what's happening. So just now we saw account. Okay, so whenever we do ACCT1 equals account 8404 and like let's say 500, whenever you see an
Right.
equal sign means arrow. Okay, remember that equal sign means
Mm,
arrow. ACC whenever left hand side the name, a name is just a name, so that's just like that. Whenever you get a new object, draw a box. Okay,
okay.
and you can do this with a pen or paper or whatever. And then in this box you can write you write the fields. So we have ID, we have balance. Each field gets its own box. Okay.
Okay.
If it's just a number, if it's a primitive data type, if it's small, it goes inside the box. So 8404 and 500. Okay.
Yeah.
I'm gonna introduce. Okay. Okay. I'll save it for later. Next, when we have account two, we say let me draw and write a new line. Let's say we say account two equals account one. What's happening is first, when we see equal sign, there is an arrow. Okay, there's an arrow. Left hand side,
Okay.
we write what's on the left hand side to the left of the arrow. Or the tail of the tail of the arrow. The right
Right.
hand side of the equal sign, ACCT1, we look at ACCT1 and we see what is ACCT1 referring to? It's referring to this object, right?
Right. So the
So
ACCT2 is also referring to that object, right?
yes, yes, exactly. So ACC2, the arrow points to the same object.
Mm.
So we clearly see the alias here. We see two names referring to the same object.
Yeah.
The box and arrow diagrams is to give you a mental model, a visual mental model of what is happening. Of course, under the hood, there might be some internal details that differ, but conceptually, this is what's happening.
Right.
For now, our box and arrow diagram is simple, but there is one thing I haven't talked about yet, which we'll revisit after our next topic. So now we're going to move to our next topic. All right. Gonna share back my Visual Studio. Let's go back to Visual Studio.
Of
I
course.
started I started the recording, right?
Yeah,
Yeah, I did.
yeah.
Okay, good. That's like my
I
biggest
have
fear is like I didn't start the recording.
yeah.
Okay, I'm now going to go all the way down to the bottom of the file. I have a task for you. Uh, Design the data definition mutable list, which is the same as a list, but both data and the rest are mutable. Okay, good luck. You may get started.
What?
Yeah. Oh,
Hmm.
use the design recipe. So step one, step two, step three, step four. Do all steps.
Okay. What was the design recipe?
So what's step
Uh,
one?
like, hmm. Uh, like we must go to the sunset, right?
Okay.
Oh, okay. So I just must call it like a table list, right? And then
Okay.
data. Does it like differ in some kind of way from a list?
Yeah. The difference is that the basically every field is mutable. Basically.
Okay. Okay. So like must be hmm, uh, okay. And oh, how do we do how do we do that? Um, Oh, how did we like okay. Oh,
See. So what's the next step of the design recipe?
like tested, right? Examples.
Okay, technically it's interpretation.
Interpretation. Okay, okay.
Yeah.
So how to interpret it? Like a list of that. Right. So like hmm, how to do that? Should it be like of type like ref?
Mm. Right. It's the ref must go somewhere, right? Where does ref go?
Mm, like before that, can test it
Mm,
out.
yes, yes. Very good. Yeah. Okay. What's the next step in the design recipe?
Mm, examples, right?
Yeah.
Mm. Oh, oh. Did you just that's okay? That's like, so that's I don't know.
Nice names.
You?
Okay.
Uh,
So for line 335, notice M link to M empty. Why not just use L of 2 there?
oh, right.
Okay. But now be careful. Now you have an alias, right?
Hmm.
So yeah, either way works, but there's a consequence to doing this. Now it's shorter, but
Hmm.
it's alias. So keep that in mind.
Right. Right. Okay. What did I do wrong?
Oh,
Hmm. Those should end with expression.
yeah. You need to end with something that gives an answer. For now, I think you can remove the check and just like leave it out in the open for now.
Hmm.
We can move it later.
Okay.
Okay. Great, great, great. Um, let me think about. Okay. I want you to okay, here's a task. Design the function add one to all that given a list of numbers adds one to each number, mutating the list. So do not produce a new list.
Hmm. Okay. Thanks.
Wait, sorry, pause. I just realized there's one more step in the design recipe.
Yeah, like template, right?
Yeah. Sorry. Can we do the template
Hmm.
first? Sorry, I just realized that because you need the template to run the function.
Hmm. Right. So I must write the template, right?
Yes.
Hmm. Okay. Right. Right. So, it's- of course. and two. Hmm, okay. Uh, so it was like this. Okay. Okay.
And M-link itself could also change, right?
Hmm.
Oh, so sorry. I should say L could also change under the M-link case. I should be more specific.
L was.
Okay, it's okay. There is one thing that this function is missing, but I think you'll figure that out as you write at one to all. So let's write that first.
Right. So right. Like to all numbers, right?
Yes.
Okay, okay. I just have to be clear. Hmm. Hmm. Okay, you can just copy the this is right. Um, okay, if it's empty, so what's okay, okay. Return oh, it should return nothing, right?
Uh, let's just return the same list, but I do want you to mutate the list. So return the same list and mutate that list. Yeah.
Okay.
Sorry, a mutable list. Yeah.
Yeah, right. Hmm. Okay, so if it's empty, it must like same thing, right? And hmm. Oh, right. I can use like ref here. Okay, but uh, hmm. So it will be like I want our like session close.
Yeah, I just realized what you said right as it happened.
Yeah, yeah.
Okay,
Uh,
all right, let's continue.
uh, then, oh, hmm. Should we value plus one and focus on rest.
Okay. And I'd like you to write tests for this.
Hmm. Right.
Yeah, I want to see
Uh,
how you write the test for this. Okay, while you do that, I'm going to run to the restroom real quick. Be right back.
uh, what did I do wrong here? Okay. Uh, where? Okay, so we have lists. Okay, so uh, uh, add one to all of L. Mm, okay, it won't be like this because it's mutable, right? Why does the like program doesn't work because of 9 3 4 1? I missed something with the dots. Oh, hmm. Okay. Can you tell me like why doesn't the program work?
Okay, I'm back.
Oh, you okay. I was like asking you questions and
Oh, sorry. I say I was using the restroom.
oh, sorry, I didn't hear that.
Oh, okay. Okay, wait. What was the question?
Why doesn't the like program work because of line 3 4 1?
Oh, yeah, yeah. That's a syntax error. Okay, I'll tell you. Okay, the exclamation mark should not exist on its own. The exclamation
Hmm.
mark not needs to come before the opening curly brace.
Okay.
Yeah, that's why.
Hmm.
Mm, okay, work on the test first, and then we'll talk about the template. Because yeah, the template is a little bit off.
Okay. So like okay. Uh, mm, we don't must like, okay. Uh, okay. It's empty, right? So I know even my cases are way off, right? So it won't be like it will be it will be like this, but the
Yeah.
first one won't work.
Mm, okay.
Hmm.
Okay, so for line 352, right? When you give it empty, I would like it to be that same empty. You know what I'm saying? Oh, wait. Oh, sorry. I brain fart. No, what you did is correct. What you did is correct. I read it as M empty, but L empty is
Oh,
correct.
okay.
Sorry.
Okay.
Pretend I
Yeah,
didn't see anything for the last 5 seconds.
of course. Uh, what can I do more? Like, definitely my template is way off.
Okay. Focus on the test for now. And okay, we've for L of 2, we verified that we get back the same object, but should there be any other tests that we should be doing?
Right. So, okay. Hmm. So if we modify this, it won't be like one, two, and three. It would be like two and four, right? Because we are like referencing to. a list of two.
Yes. Yeah.
Hmm. So I guess this will do, but this, of course. Uh,
Remember the three, four steps of our testing.
what?
Remember there are three steps to our testing? What are the three steps?
Testing.
Yes. The three steps to testing with mutation.
Mm. Oh, okay. So, hmm. Okay, okay. So can I do it like this and then uh, and okay. I can't call it. Okay. This I would leave it at as it is, but mm, uh, right. Mm, okay. And I can only check that. Mm, hmm. How to check if that like the second element has changed?
How
Uh,
do we check that?
mm, I don't know. I don't know.
So
Hmm.
there are two ways. The
Okay.
first way is that we already have an alias, right, to the second element.
Right.
So that's one way. We can use the alias.
Okay. Okay.
The,
So
the other way is just rest dot first.
really,
Yeah, it's not pretty, but yeah. Sorry, in your
okay.
case, it's rest of value.
Okay.
Yeah.
Mm, okay. And so you can change that. Rest. The value is mm, 4, right? And
Uh,
rest dot rest.
so you have to use exclamation mark for rest because that's mutable. So it's rest
Mm,
exclamation mark value, rest exclamation mark, rest. Okay, so
oh,
sometimes they actually instead of calling it exclamation mark, they call it bang. So rest bang value, rest bang rest. So if I say bang,
bang.
I'm referring to the exclamation. Yeah, bang, like
Huh,
bang bang,
huh,
like gun.
okay. Okay.
I don't know why. I think it's like they call it that because it's like a gunshot, but I'm not sure. Yeah, bang.
Really? Okay.
So rest bang value, rest bang rest. In fact, the reason why they use exclamation mark is to is because mutation is very scary and like has a lot of consequences. So it's to divert your attention to is to get your attention to that fact.
Okay.
It's like, oh, warning, danger. Yeah.
Mm.
Okay.
Oh, mutation.
Yep. Okay. Yeah, I think the test could use some setup. Okay, I want to talk about something else first, but if you have time at your own time, I do want to talk if you have time. Fix the setup. Think about how to be able to reuse the setup for if we make more tests, if we make more function procedures for mutable lists, which we will. Okay. But I want to go back to the template. So back to why we're getting an error at the dot dot dot. The value exclamation mark. Does it make sense for value to have an exclamation mark? What happens if value is a number?
Right.
So a value, I would remove the exclamation mark.
Okay.
For rest exclamation mark, when you say exclamation mark, right, bang, you're saying you intend to mutate rest. But should you be mutating rest here?
Hmm. Yes.
Well, not directly. If we want to mutate rest, we should be delegating to the
Mm.
mutable list template, right? We let the template to deal with it.
Okay, so we should only be like mutating value, right?
Yeah, so we should be mutating at our current level. We should be mutating L and
Okay,
no
okay.
more. We shouldn't look past rest. So rest bang can just be turned to rest.
Okay.
Okay. There is one more thing missing in your template, but fix the body of add one to all first,
All right.
and we'll think about how to fix. And I believe there will be some. Oh, MMT is unbound. Oh, typo.
Mm.
It's not M empty, right? It's something else.
Oh, right. Right. Second time. And what is up with the X's?
Is it X? Where's the X coming from?
Mm, it's a number, right?
Number, yes. Excellent.
Yes. Again, can spell. Ah,
Interesting. What is this? Wow.
okay.
Woo. Wow. Okay, I think that's something I should have told you but didn't. I'm Googling this right now.
Oh, of course. Yeah. Why not?
The heck?
Mm.
Okay, okay, this is part of your challenge. Figure out what that means. I didn't read carefully enough.
Maybe your book is wrong.
Nah, I guess I didn't read far enough into the book. I thought I did.
Okay.
I swear. Hmm.
Is the book also written by a university?
Not my university, no.
Okay, okay.
Actually, wait, I think one of my professors from my university worked on it. So yeah, technically, yes. It's a collaboration between multiple universities.
Really? Okay.
Let's see. Hmm.
Mm. It's not from Pirate to Python, but from Pirate to C++.
Yeah, in your case. Wait. Cases on Raphael needs to use Raf.
Hmm.
Oh, wait. I think I know. Sorry, I'm going to modify the code. I think I know what's up.
Of
Okay, I
course,
figured it out. Okay, line 348. You have to write ref.
348.
Yeah, I wrote back the ref. It was there just now, I
Really?
deleted it. Yeah, it
Really?
has to be there. Okay, interesting.
Okay.
I think I
Uh,
know why, but I'll let you fix the rest of the thing first, and then we'll talk about
oh,
that. Okay, since I started you a bit late, I'll give you like maybe a few more minutes
oh,
if you
of
have the
course.
time. Yeah.
What is wrong here?
Let's
Value
see.
is the left side was 1 and the right side was. But I called the function right.
Yes. Yeah, no. There is no mistake here. The test should be failing. Okay, maybe I will call it here. Um,
Okay,
but I want to give you a hint.
of course.
But I want to tell you the hint without giving too much away. Let me think about it.
Yeah.
Okay, line 358, I recommend adding back that is test to make sure that you're getting back the same object. That's my hint for you.
Mm, okay.
All right, that's all. Your homework is to fix the test. If you have time for the homework, whenever I give homework, like it's not like I'm holding a gun to your head, it's like if you have time, you
Yeah,
can do it. Fix the tests.
you're not like saying bank.
Yeah, I'm not saying that.
Okay.
All right, okay. Let's wrap it up here, and yeah, I'll see you tomorrow.
See you tomorrow.
All
Yeah.
right, good luck, Simon.
Bye.